Okay, guys, this is my first attempt filming at home. I'm having a little bit of trouble figuring out how to get some of the settings to work on this, hooked up through my computer, but I think this will work for now. So it's nice getting a chance to kind of talk to you guys a little bit, even though it's from far away. I hope you all are doing well. And that just gives you something to do while you're at home. So I'm going to go through the AP Calculus problem from the 2013 test. This is question number 5. This is our packet from class that we started. You can find this on Google Classroom. I believe it's under the Unit 5 Day 8 materials. But we're going to do the one on the back. I tried to pick one that kind of did a good job doing an overview of what we've done so far this unit. So let's jump in and see what we've got. So it says let f of x equals, so the function 2x squared minus 6x plus 4, and g of x equals 4 cosine of 1/4 pi x. Let R be the region bounded by the graphs of f and g as shown in the figure above. So part A says to find the area of R. Before I even do that, notice that this is question number 5 from this year's AP, which means this is a non-calculator problem. So anything I have to evaluate, I'm going to have to evaluate by hand. Okay, so we need to find the area of R, and we know if we want to find the area of something, we're going to integrate the top curve minus the bottom curve. And this isn't great notation, but just helps us remember what we need to do for this problem. Well, if we're going to need to do that, we need to figure out which curve is the top curve and which curve is the bottom curve. So you'll notice I have f of x, and this is a quadratic. This is going to be a quadratic that opens upward because it's a positive x squared. So I have a good feeling that this thing here is going to be f of x, but let's check the other one and see. This is a cosine curve. There's no phase shift on it, so it's going to start at its normal starting point, which is at the top. So this is going to be my cosine curve. So I'm going to label on my picture that this top curve is g of x, and this bottom curve is f of x. So I remember for the future. So if I go into part A, I'm going to integrate from here to here. Well, they've given us nice clear markings here, so I know that this point here is over 0 up 4. And this 2 tells me that this is over 2 up 0. Because I know the screen's a little darker than normal. Hopefully you guys can see okay. Okay, so when I integrate, I'm going to go from 0 to 2. And I want my top curve, which is g of x, minus my bottom curve, f of x. I'm integrating with respect to x, so I'm going to put this in brackets and throw a dx at the end. If I don't put those brackets, in this case, we might be okay because I'll group it, but make sure you guys put those brackets to be clear that this d of x is integral. It goes with everything in between. Okay, they want us to find the area, so we want to get a numeric answer. So I'm going to have to start integrating this by hand because this is a non-calculator problem. So what I really have is the integral from 0 to 2 of g of x, which is 4 cosine of 1/4 pi x, minus f of x, which is going to be 2x squared minus 6x plus 4. Okay. So if I want to integrate this piece here, I notice that I have cosine of stuff, which makes me think that I need to use u sub. But I notice if I take the derivative of this stuff, the derivative is just going to be a number. It's 1/4 pi, which means I can use my shortcut. So I'm going to have 4. The antiderivative of cosine is sine. I'm going to plug in the stuff. But then my shortcut says now I have to divide by the derivative of stuff. So I have to divide by 1/4 pi. Okay. Minus. Now I'm going to integrate this. This is going to become x cubed. So I have to divide by 3. Minus. This is going to become x squared. So I have to divide by 2. And I'm evaluating all of this from 0 to 2. So I can't leave it here. I still have x's in my answers, but I can, I'm going to plug this 2 in and this 0 in and subtract those values. But once I plug them in, I don't have to simplify. So if I plug in 2, I want to simplify that dividing by 1/4 is the same as multiplying by 4. So what I really have is 16 over pi sine of 1/4 pi times 2 minus 2/3 times 2 cubed minus 3 times 2 squared plus 4 times 2. Okay. Now I would plug in 0. if I plug in 0 into this, I'm going to get sine of 0, and we know sine of 0 is 0. And if I plug 0 into these, I will also get 0. So I don't actually have to plug in 0. This is going to be my final answer. However, if you are getting like tripped up on the test and you can't remember if sine of 0, 0 or cosine of 0, 0, you can just plug in 0 into all of this and put it at the end and subtract it out. But this is my final answer here. If this was on the AP exam and they were scoring it, here's how you would get your points for this part. This integrand here would be 1 point, just understanding which function was on top. So g of x minus f of x. They'd give you 2 points for your antiderivative. My guess is that if you got this portion right but this portion wrong, you get 1 point or vice versa. And then 1 point for your final answer. Okay, so that's part A. Let's move on to part B. Part B says, write but do not evaluate, that's nice, an integral expression that gives the volume of the solid generated when r is rotated about the horizontal line y equals 4. Now remember, on the AP exam, you can't use highlighters. I'm going to use them right now for a visual, but on the AP exam, you wouldn't get to use this. I would just use your pen, use dotted lines, things like that. So I would probably normally just do a dotted line here with the pen that I was using, but I'm going to use the orange just so it sticks out. So we're revolving around this line. And I'm revolving this solid. Okay. Well, I can see that when I revolve this yellow solid around that orange line, there's going to be a gap here, which means I'm going to have a hole. So when I do revolutions with a gap, remember, I'm going to use the formula pi integral of big R squared minus little r squared, where big R is the farther distance, so from this line to the farther part of that yellow region, and then I'm going to subtract out, I need the R for the gap, so that's going to be my little r. So this is going to be my big R, this is going to be my little r. So if I go down here, hopefully we can still, oh, we can't quite see it, but hopefully you guys have that on your paper. So when I jump to part B, I'm writing an integral expression to find the volume when I rotate around y equals r. I've got my big R, so let's start with that. It was the distance from the line, which was y equals 4, to the bottom of that yellow curve. Well, the bottom of it was f of x. Okay. Little r was the distance from the line to the upper curve, g of x. And you can leave it just like that with our functions. Okay. So now for the volume by revolution, I'm going to have pi. I'm integrating still from 0 to 2 as I go from right to left. I've got big R squared minus little r squared. They did say right, but you don't have to evaluate this, and you can leave it with f of x and g of x in there because they've defined what those are for you. Okay. If you got this on your AP exam, they gave 1 point for this coefficient here and the bounds, and then 2 points for the integrand, the stuff on the inside. Oops, I forgot my squared here. I'm not sure how they gave partial credit for this. I guess if you have a minor answer, like maybe you forgot one of the squareds or something like that, they'd take off 1 point. But that's how they grade it. It was 2 points for the full integrand. So part C says the region R is the base of a solid. For this solid, each cross-section perpendicular to the x-axis is a square, right? But do not evaluate an integral expression that gives the volume of the solid. So since we can't see my picture anymore, I'm going to just redraw it down here real fast. It looks something like this. Okay, so here's my area. They told me that the cross sections perpendicular to the x-axis is a square. So my cross sections are running this way. Okay. And for each one of these, there's a square coming up out of the page. So this is the base of the square, and coming out of the page at you is a square. Okay? So we've learned that if I need to find the volume by cross sections, what I really need to do is integrate the area of a cross section. Well, because my cross sections are squares, my formula is area equals side squared. Okay? Well, we know this is the base of my square. That's one of my sides. So if I can figure out what the length of this is, I can square it to find the area. Well, this length here, this distance, is the difference of top minus bottom. And we saw from earlier that the top curve is g of x, and the bottom curve is f of x. Okay, so for this problem, if I want to find the volume by cross section, I'm going to integrate from the beginning 0 to 2 of the area. Well, the area is side squared, and each square, is a side squared, and a side is g of x minus f of x. So I've got a side squared, okay? And that's going to be my answer. On the AP exam, this was graded, I believe it was 1 point for your bounds and your integral, and then 1 point for your integrand. Okay. So guys, I hope you found that was helpful. I'm still getting used to the system at home, but hopefully this will keep us connected over time. I hope you guys are doing well. If you need anything, feel free to shoot me an email, and hopefully I'll see you all soon.